In this section, we're going to learn other ways we can use synthetic division. This is going to help us to factor things that are bigger polynomials that we haven't been able to factor in the past. And so now we will be able to. So the first thing you want to look at is to see if you have any traditional methods to factor this polynomial. And when there was 4 terms, we often talked about factoring by grouping the first 2 together and grouping the second 2 together and going from there. But this one, I can tell you right now, is not going to get anywhere with that method. So we have to have something else. Keep in mind when you divide something into this polynomial, if it goes evenly into, in other words, it has a remainder of 0, then that means that it is a factor. If it goes evenly into something, it's a factor. So therefore, we want to find something that we can divide into this polynomial that will come out with a remainder of 0. Now, you could just start guessing and trying different things, but there's a little bit better method using the graphing calculator that could give you some idea of what you're looking at. Using the y equals button on your calculator, put in that polynomial into your graphing part of your calculator. Hit graph, and then also zoom in 1 time. Now, once you have it on your graphing screen and you've zoomed in 1 time, you should be able to see the little tick marks pretty well. And as it was graphing, hopefully you saw where it was graphing. And these are the units on my graphing calculator. So what it looks like is there is a x-intercept here and x-intercept here, which are both between 0 and 1 or 0 and -1, so that means they're going to be fractions or decimals. But then there's this nice one that goes right through the tick mark, and so that tick mark is at 2 to the right. And so we're going to assume that probably 2 would be a good number to synthetically divide, and the reason for that is it looks like it's a 0 of the function or an x-intercept of the function. And if it is, we'll know because it'll have a remainder of 0. So let's try to synthetically divide this. Remember, you put just the coefficients. Make sure there's no terms missing. We've got x to the third, then we go down to x to the second, x to the first, and then the constant that has no x. And that means there's a spot for everybody, so we don't have to put any zeros to fill in the space. We drop the first term down. We multiply 2 times 15 and put the answer there. We add down, and then we multiply 2 times -2 and put the answer there. Then we add down, then we do 2 times -1 and put the answer there. Then when we add down on that last step, we do get 0. That's good because that means that 2 is definitely an x-intercept. It's definitely a 0 of the function. And so what that means is if we think of this as a factor, remember we were able to take zeros and make them factors, and take factors and make them zeros. And so you may remember that in its factored form, this is called a 0 of the function or an x-intercept. This is called a factor, and in the factored form it always shows an opposite sign. So if it's +2, it'll show up as x minus 2. If it's -2, it'll show up as x plus 2. Then you'll recall that what all these numbers at the bottom of the synthetic division mean. You have a remainder here, which is 0. Then the very next one to the left is a constant. Then this one will be your x to the first coefficient, and this one will be your x to the second coefficient. So now we can write what the other factor is, which is 15x to the second minus 2x to the first power, so we'll just write x, minus the constant 1 with no x. And so these are two factors of that polynomial. So we have gotten part of the way there. Let's see what happens next. So because 2 synthetically divided into the original polynomial coefficients with a remainder of 0, we know that x minus 2 is a factor. We also know that what was left underneath on the synthetic division was also a factor. Because if you multiply these two things, and you could try it, if you multiply those two polynomials out, you will get the original polynomial. So this one you cannot factor anymore, but this other one you can factor some more. So we're just going to bring the x minus 2 down and then use our trial and error factoring or unfoiling to factor this thing. So again, what you want to try to do, if you remember about factoring, this is just my method, is you write factors of 15 over here, write factors of 1 over here, and then try to see what works. So I'm going to try the 3 and the 5 first, because I like to start at the bottom of my list, and then I'm going to put an x and an x on each one to give us the 15x squared. So first times first gives us the first. Then last times last should give us the last, but we're not going to worry about the sign yet. We're just going to put a 1 here times a 1 here, and we'll worry about the sign in a minute. So we've got our inside loop and our outside loop. We've already done the first and the last part of our FOIL. Now we're just trying to do something with our OI in the middle of our FOIL. And so the inside and outside products give us 5x if you multiply and 3x if you multiply. And our goal is to get a negative 2x. And so the signs that have to happen on the 5 and the 3 to make that add together to give you negative 2x is a negative on the 5 and a positive on the 3. Therefore, we put the first sign in the first spot, the second sign in the second spot. Just double check that that does actually give you a negative 1 when you multiply this term times this term, and that checks out as well. And so now we have fully factored this polynomial. One of the factors, we kind of cheated and got it off the graphing calculator. Another one of our factors, the other two factors, we got from a factoring method we already knew how to do. So this is the factoring of the original polynomial. So one of the main purposes for factoring would be to solve an equation that has that polynomial in it. So now I've made this thing an equation by adding an equals 0 on the end to it. So let's say this was the original problem instead of a problem that just said factor this polynomial. Now it's saying solve for x. So this is a new problem, but it's the same polynomial. And so what you want to do is when the polynomial is on the left and you have a 0 on the right, then you can use a zero product property to factor and solve. The zero product property says that if you have a bunch of factors times each other that equals 0, you are allowed to set each factor equal to 0 and solve each little equation separately. The reason the zero product property works is because if you have something times something equaling 0, there's a special property that says one of those three factors has to be a 0. It doesn't matter which one, so we're going to solve for all three, but if any of those factors equals 0, when you multiply, you're going to get 0. And so let's solve all three of these. So now we have the three solutions for x: 2, 1/3, or negative 1/5. Any of those, if you plug them into the original equation, would equal 0.